Okay, hello everyone in a new video. So we have reached part 7 of chapters 5 and 6 related to mechanical actions, forces and weight. So in this one we are going to solve the following exercises. Let me start by exercise number 10, page 119. So the title of this exercise is Weight on the Earth and on the Moon. On December 14, 1972, Eugene Cernan was the last man to walk on the moon and will perhaps be so forever. Before going on his mission to the moon, Egan weighed himself. His mass is equal to 70 kilograms. So we know that the mass of this person is given by 70 kilograms. In 10.1, they are telling me calculate the magnitude of his weight WE on Earth. So we need to calculate the weight corresponding of this man on Earth, and they are telling me let G is equal to 10 newtons per kilogram on Earth. So the weight is equal to M multiplied by G. So notice that here the weight carries the label E and the G carries the label E. So it is WE, GE. Here E stands for Earth. Now the mass doesn't carry a label E. Now we will explain why. So it's equal to 70 multiplied by 10, which is equal to 700. Since everything is expressed in the SI, M and GE, then W will be expressed in the SI, which is in newtons. So WE is equal to 700 newtons. Now as for 10.2, they are telling us, does Egan's mass vary on the moon? So here there is a question mark. And the answer is no. By vary, it means does it change? So the answer is no. Vary means it changes, because mass remains constant. Then in 10.3, they are telling us calculate his magnitude of the weight Wm on the moon. Let Gm is equal to 1.6 newtons per kilogram on the moon. So the weight is equal to M multiplied by G. So since we are discussing the weight on the moon, so it carries the label M, as well as Gm, because we are discussing the weight on the moon, or G on the moon, it carries the label M. And here's the thing is that because the mass is the same on Earth and on the moon, it doesn't changes, so it will not carry any label E or M. Now here we know that the value of the mass of this person is given by 70. And the Gm is equal to 1.6 on the moon. And plugging this on the calculator, then his weight is given by 112. Since everything is expressed in the SI, M and G, then the value of W will be expressed in the SI, which is in newtons. Then Wm is equal to 112 newtons. Now in 10.4, they are telling us calculate the ratio WE over Wm. So we need to calculate the following fraction, WE over Wm. So WE over Wm is equal to, the weight on Earth is 700 and the weight on moon is 112. Now plugging this on the calculator, we get that 6.25. So WE over Wm is equal to 6.25. And now notice that in this case we have a unit, in this case we have a unit, in this case we have a unit, but in this case we don't have a unit, because WE over Wm is a ratio of two quantities that have the same unit. So whenever we are calculating ratios of two quantities of the same unit, we don't have unit, okay? So simply because here we have Newton and Newton, so they cancel out. So here, for example, if we place a Newton by mistake, then the answer will be considered wrong. Now in 10.5, they are telling us deduce why Egan is able to jump more easily on the moon than on Earth. So the direct answer of this question would be because the weight on moon is less than the weight on Earth, which is correct. But notice that here they are telling us deduce, and deduce it means that we need to use the previous part. In the previous part we have determined this ratio, which is WE over WM, which is equal to 6.25. Now, first of all, in order to solve this question, this is the first time we overcome such type of questions. So in order to answer this question, notice that this number is a number which is greater than 1. So whenever we want to use the ratio in order to answer such type of questions, we need to compare this number by 1. So this number is greater than 1, which means that WE over WM is greater than 1. Now here 1 is divided by 1, so if we cross multiply, which means that WE is greater than WM. Then Egan can jump more easily on the moon. And now let's move to the next exercise, which is exercise number 11, pages 119-120. The title of this exercise is Unknown Planet. During a space mission, an astronaut reaches an unknown planet. In order to identify it, he measures the magnitude of weight of different objects with known masses. The results are summarized in the following table. So in the first row we have the mass, the second row we have the weight, and the third row we have the ratio W over M. So in 11.1, they are asking us to calculate for each object the ratio W over M and write it down in the table. So W over M, so if we are dividing 17.2 over 2, now this is equal to 8.6, and here the unit is in Newton per kilogram. Although this is a ratio, but ratio of different quantities, not the same quantities. Okay, so now 21.5 divided by 2.5, you can check that it's also equal to 8.6 newtons per kilogram. 34.4 over 4 is equal also to 8.6 newtons per kilogram. 64.5 over 7.5 also equal to 8.6 newtons per kilogram, and 86 over 10 is also equal to 8.6 newtons per kilogram. So this is 8.6, 8.6, 8.6. So now in 11.2, they are asking us, is the value of the ratio W over M the same? So yes, it is constant. Now in 11.3, what is the value of the gravitational acceleration on this planet? So they are asking us about the G. We have that W is equal to M multiplied by G, and we are interested in determining the value of G. So constructing the triangle of this formula, here because we have multiplied, then W will be at the top, M and G at the bottom, putting our hand over G. So G is equal to W over M. But also we have calculated this ratio. So W over M is equal to 8.6. and here because the unit is in Newton per kilogram, which is here in Newton over kilogram, so this will be Newtons per kilogram. Now in 11.4, they are asking us, by referring to the table below, identify the planet on which the astronaut is. So for each planet we have a specific value of g, and in this case it's obvious that the planet is Venus. So the planet is because g is equal to 8.6 newtons per kilogram. Okay, so that's it for me in this video, guys. In the next part we'll complete solving exercises of this chapter.